Hi, in this video we will discuss about the position of the resultant force. Position of the resultant force. Okay. So while solving the problem, in the problem, if the system of forces given in the problem are coplanar concurrent system of forces. Okay. If the system of forces given in the problem are coplanar concurrent system of forces means all the forces passing through the single point. The line of action of all the forces passing through the single point. Okay. If the system of forces given in the problem are coplanar concurrent system of forces, then the position of the resultant force will be known. Position of the resultant force will be known. How it is known? See, as the line of action of all the forces passing through the single point, the line of action of resultant force should also pass through the same point. Okay, that is how the position of the resultant force is known with respect to coplanar concurrent system of forces. For example, see here in the one of the previous classes, I have solved one particular problem. So this is the coplanar concurrent system of forces. For this, I have determined magnitude and direction of the resultant force. Correct? Magnitude I got it as 246.9 Newton and direction 80 degree. Okay. And sigma fx I got 43.46, sigma fi 243.04 means sigma fx I got plus 43 plus 243. Correct? Means both are positive means it will be in the first quadrant. Resultant force will be in the first quadrant. So 246.9 Newton, it will be there, it will be like this. 246.9 Newton, which is the resultant force, and its inclination is 80 degree. And its inclination is 80 degree. Therefore, for this concurrent system of forces, we are able to predict position of the resultant force. Okay. Therefore, if the number of forces given in the problem are coplanar concurrent forces, then position of the resultant force is known. Position of the resultant force is known. Now I will take one more example. I'll consider a plane. I'll consider a plane area. Plane. Now I will apply few forces to this plane. Force F1, force F2, and force F3 at an angle of 30 degree. Force F4 at an angle of around 60 degree. Okay. So here whatever the system of forces given here are coplanar non-concurrent system of forces. Okay. For this we can find the resultant force, magnitude of the resultant force and its inclination by finding sigma fx and sigma fi, and by using the formula root of sigma fx square plus sigma fi square, and by using the formula tan inverse of sigma fi by sigma fx, you can find magnitude and direction of the resultant force. But when it comes to the position of the resultant force, here it is very difficult to predict the position of the resultant force. Okay, the position of the resultant may be here, or it may be like this here. Okay, it may be like this here, right? So here, in case of coplanar non-concurrent system of forces, the position of the resultant force will not be known. It will not be known. Okay, it has to be predicted by doing the calculation. It has to be predicted by doing the calculation, because whatever the system of forces given here are coplanar non-concurrent system of forces. Okay, all the forces are randomly distributed across the plane. Therefore, here we don't know position of the resultant force. Okay, therefore in the problem, if coplanar non-concurrent system of forces are given, along with finding magnitude and direction of the resultant force, we should also find position of the resultant force. Okay, we should also find position of the resultant force. Now let us see how to find this position of the resultant force. Okay, I'll take the same rectangular plane. What we'll be doing is, now for the coplanar non-concurrent system of forces, you have to find the position of the resultant force. To find this position of the resultant force, what we will do, basically we will consider one reference point. Okay, we will consider one reference point. That reference point may be here, or maybe here, 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 or anywhere. Okay, with respect to that reference point, okay, we will predict position of the resultant force. Assume that this is the point O, this is the point O. With respect to this point, the position of the resultant force is to be determined. Position of the resultant force is to be determined. Assume that this is how the resultant force is acting for the above system of forces. For above system of forces. So in this case, what we will do, with respect to the point O, we will find x-intercept, x-intercept, we will find y-intercept, and we will also find perpendicular distance of this reference point O from the line of action of the resultant force. Okay, we will find perpendicular distance of point O from the line of action of the resultant force. Okay, so if you know x-intercept, y-intercept and d, we can mark these points. Joining both the points, we can predict the position of the resultant force. Okay, this is how we will predict position of the resultant force in case of coplanar non-concurrent system of forces. Now question comes, how to find this x-intercept, y-intercept and d. There are formula to find these coordinates. Okay, therefore the x-intercept is equal to, the formula is sigma m by sigma fi. Sigma m by sigma fi. What is sigma m? Sigma m is sum of moments of all the forces about the reference point, point O. Okay, sum of moments of all the forces about point O. For example, if you are finding position of the resultant force with respect to another point A, you have to find moment about A divided by sigma fi will give x-intercept. Okay, this one, this length. Okay, so x-intercept is equal to sigma m by sigma fi, where sigma m is moment about the reference point. Okay, so in the problem, this reference point will be given. Find the position with respect to point O, find the position with respect to point A, like that it will be given. Okay, so with respect to the given reference point, we have to find the position of the resultant force. Similarly, the formula for y-intercept, formula for y-intercept is equal to sigma m by sigma fx, where sigma m is moment about the reference point O, and sigma fx is algebraic sum of forces in x direction. And formula for d, what is d here? Perpendicular distance of the point, reference point from the line of action of the resultant force. Okay, for that formula is mod of sigma m by r. Okay, mod means whatever the sign, it may be positive or negative, you have to put the answer with positive sign only. Okay, so this is how we will predict the position of the resultant force if the system of forces given in the problem are coplanar non-concurrent system of forces. Okay, thank you.